Hey guys, we are going to move into Unit 6 and talk about L'Hopital's rule. There are only two topics that we're going to touch on Unit 6, and then we'll get you into some antiderivatives so that you're prepared for whatever comes next. We are looking at limits again, which was one of the very first things we did. We did that pre-calculus review. And then we started to discuss limits. So what we are going to do is tackle that 0 over 0 or infinity over infinity situation again. There's some other types out there, but we don't need to worry about those crazy details. We'll just get into the main ones. So L'Hopital's rule is used to evaluate the limits of quotients, the limit as x approaches a of f of x over g of x, where as x equals a has an indeterminate form, which means that it was 0 over 0 or infinity over infinity. You may replace, what you can do with L'Hopital's rule is replace f of x and g of x with f prime of x and g prime of x, meaning the first derivative of each. So L'Hopital's rule, assume that f of x and g of x are differentiable on an open interval containing a, and that f of a equals g of a, which equals 0. So they're both 0. Then by L'Hopital, you can find the derivative of the top piece and the derivative of the bottom piece. Now, this is not a quotient rule. It's the derivative of the top and the derivative of the bottom. This also holds true if you have infinity over infinity, both positive and negative. So example 1, what does this look like? Use L'Hopital's rule to evaluate the following. Well, the first thing that you need to do is see, well, what do you get? So with any limit problem, and this has been a long time, this is the first thing that we did probably in February, we would say that the limit as x approaches 1 of x squared minus 1 over x minus 1, when we put in that 1, we get 0 over 0. Now, this is not equal to 0 over 0. This is this indeterminate form. It's not a real number. It's not 1. It's not 0. It's not infinity. Yeah, we're supposed to have a meeting here shortly. It's not any of the above. So what do we do? Well, in the past, we would factor. I'll show you the old way we did this. We said the limit as x approaches 1. We said this was x minus 1 over x plus 1 all over x minus 1. And then we would cancel, if you remember, the x minus 1s. And so we would have the limit as x approaches 1 of x plus 1. We put 1 in for the x is equal to 2. So what I'm saying is by L'Hopital, the new way to do this, I can do it without factoring. I don't need all that algebra. I can find the derivative of the top and the bottom. The limit as x approaches 1, the derivative of x squared minus 1 is 2x. The derivative of x on the bottom is 1. So now I take this 1 and replace it for this x. So 2 times 1 is 2 divided by 1 is 2. And I get the same thing. I get the same thing. The thing that you have to remember, and this only works, is if you have 0 over 0 or infinity over infinity. If you get an answer like 2 over 3, you're done. The answer is just 2/3. L'Hopital will not give you the correct answer if you attempt to find the derivative of the numerator and denominator. So 0 over 0, infinity over infinity. This is always a nice lesson to do in class. Now, example 2, use L'Hopital's rule to evaluate the following. So if we have this, we have to put 0 in place of the x. So this is e to the 0 minus 1 over cosine of 0. Cosine of 0 is 1. If you get stuck on that, consult your unit circle, minus 1. So e to the 0 is 1, minus 0 minus 1 over 1 minus 1. This is 0 over 0. So yep, we got that 0 over 0 piece. We're allowed to use L'Hopital. So this is my notation. This is not an official calculus thing. L'Hopital's rule will be the limit as x approaches 0. The derivative of e to the x is e to the x. The derivative of x is 1. The derivative of 1 is 0, so we don't have to worry about that. The derivative of cosine is negative sine. And the derivative of 1 is 0. So we got to check out that 0 again. This becomes e to the 0, which is 1 minus 1. And then in the denominator, sine of 0, well, that's 0. So now I'm left with 0 over 0 again. Well, shoot, that's not an answer. So we got to do L'Hopital. Again, I'm going to switch colors here so it looks different. And that's the thing about L'Hopital. You can do it more than once. There's no end to how many times you can do it. Now, for the problems we're talking about, it should be once or twice. If you find yourself doing it 4 and 5 times, there might be an error. The derivative of e to the x is e to the x. The derivative of 1 is 0, so that drops off. In the denominator, the derivative of negative sign is negative cosine. Now, let's try our x approaches 0. So e to the 0 is 1. In the denominator, cosine of 0 is negative 1. So we have a negative 1, and that's our answer. There you go, voila. So that's in place of all the factoring and the conjugate pair and the replacing the trig function with simpler trig forms. And I'm trying to think, simplify the denominator. L'Hopital is very nice for all of those things. We have L'Hopital's rule to evaluate the following. This one's infinity. So if I replace those x's with infinity, this is infinity squared plus 4 times infinity, which is infinity, over 9 times infinity cubed plus 4, well, that's just going to be an infinity cubed. This is infinity over infinity. So before we talked about rules with the power in the numerator and the power in the denominator. If the power in the denominator was greater, the answer was 0. If the power in the numerator was greater, the answer was positive or negative infinity. If the powers were the same, the answer was the coefficient or the ratio of the coefficients in the front. So what happens with L'Hopital? L'Hopital says, hey, let's find the derivative. So the derivative of the numerator is going to be 2x plus 4. The derivative of the denominator is 27x squared. Now, if I put infinity in here, I still have infinity over infinity. I'm not there yet. So remember I said we could do L'Hopital more than once. So let's do it again. The limit of 2x, or excuse me, the derivative of 2x plus 4 is 2. The derivative of 27x squared is going to be 54x. Now if I put infinity in here, this is 2 over 54 times infinity, which is 2 over infinity, which is 0. And that's my actual answer. Your old rules from before, if that denominator had a greater power, that's still true. You can still use that, but L'Hopital does work. So students always get frustrated. They're like, well, why didn't you show us this earlier on? Well, I need to make up one more example in here. We didn't know what derivatives were, so we couldn't do it without a derivative. So it's the chicken and the egg, which came first, the derivative or L'Hopital. We couldn't do a derivative without limits, and you can't do L'Hopital without derivatives. So this is the way that we teach it. Pop in one more here for me, example 4. I thought I typed it in, but I guess I did not. Let's find the limit as x approaches infinity of x over natural log of x. I think this shows up on one of the worksheets that I gave you. If we put infinity in place of x, this is infinity in the numerator. If I put infinity in the bottom, this is the natural log of infinity, which is still infinity. Infinity over infinity is indeterminate. So we want to find L'Hopital. The derivative of the numerator is 1. The derivative of the natural log of x, it's been a while, but the derivative of natural log of x is 1 over x. So this looks a little funny. It looks like 1 over 0, which isn't really a number. We can't divide by 0. But come back here to this place, this point, and be a good algebra student. We're going to multiply the numerator and the denominator by x. It's not very bright, is it? Let's try this color. By x. So if I multiply by x over x, we have the limit. As x approaches infinity, the numerator will be x and the denominator will be 1. Or instead of dividing by the fraction, you can multiply by the reciprocal. That's the same thing. Now if I replace x with infinity, I have infinity. And that is the correct answer. So great job. Try the practice problems, the worksheet I gave you. I didn't give you any delta math. I'm recording a video, you see. I didn't give you any delta math problems. They were very, very abstract. I did not like them. So I just gave you some very basic, straightforward worksheet problems to try. So do your best. We're almost there. We're going to do this. I'm going to teach you a little bit about antiderivatives because you can't leave calculus without knowing about antiderivatives. So haven't heard from a bunch of you in a while. Keep me posted if you need anything.